Amit give the talk.
Yeah, live start.
Good evening to all those who are joining us here in India, and good day to everyone else from around the world. Welcome to the second talk of our TechToks series. I hope many of you had the occasion to join our first talk and are here to listen to Amit Sinha. I'm really delighted that Amit Sinha has agreed to join us today for this session, for this talk. A brief introduction about Amit. Amit Sinha is President, CTO, board member of Zscaler. Under his decade-long leadership, Zscaler has grown from a startup to a 40 billion in market capitalization and established itself as a dominant leader in a new category it created, secure digital transformation for enterprises. Amit is directly responsible for strategy, R&D, operations, and support for the entire Zscaler platform and all its products. Dr. Sinha is a skilled entrepreneur and technology leader and who has driven the research and development of disruptive security and wireless technologies at both startups and market-leading organizations. Prior to Zscaler, he was the CTO of Motorola's enterprise networking and communication division, delivering wireless LAN, security, and infrastructure solutions. He was the CTO of Air Defense, which was acquired by Motorola, and chief technologist at Engim, a Wi-Fi chipset company he co-founded. Dr. Sinha earned his PhD in EECS from MIT and his BTech in electrical engineering from IIT Delhi, where he was also awarded the President of India Gold Medal. He has authored over 25 journal and conference papers, contributed to 3 books, and is the inventor of 36 US patents, which are granted or pending. He has been featured in several prominent media outlets such as the Wall Street Journal, CNBC, and CNN. I'm delighted that Amit has joined us today for this talk. Amit is going to be talking today about cybersecurity, and in particular about zero trust based cybersecurity in the cloud and the mobile world. Welcome, Amit, and take it from here.
Thank you, Professor Garg. It's my pleasure to be here, and thank you for inviting me for the IIT Delhi Tech Talk series. I really like the name, and happy Diwali, everyone. Hope all of you had a good Diwali week. So I'm here to talk about some of the trends that we see in cybersecurity from a little more of an industry lens. I know some of you might be working in academia from a crypto perspective on protocols and just hardening systems. But this is sort of some of the big trends that we see as we talk to big businesses. So let me start with a few stats that you might have seen out in the media. You know, cybersecurity has become a staggering $170 billion industry. And if you're wondering why, you know, here are some interesting facts from various outlets, and you can Google them and find them yourself. There's a cyber attack that's happening pretty much every minute, actually about 39 seconds or so. And what is very disturbing is that it takes, on average, 207 days to identify that an organization has been breached, and about 280 days to contain it. If you just look at ransomware, and this has become you know, almost a pandemic, the cost of ransomware damages in 2021 is estimated to be north of $20 billion. Right? It can cripple your business. You know, lock you out of your own machines and servers, and this double and triple extortion attempts that we hear about very frequently. About 1 in 13 websites these days have some sort of malware, right, in it. Could be, you know, crypto mining JavaScript that you didn't even know and is chewing up your CPU to mine Bitcoins, or something more malicious. About the other, you know, interesting thing is the world is moving more and more towards a default SSL. You know, 95% of websites that we see are all encrypted, And while that gives privacy and security to end users, it also allows hackers to leverage those same encrypted channels to attack an organization. And at the end of this, why do people do it? Because it's lucrative, right? You can extort millions of dollars with a successful ransomware attack. And if you get access to data, data is gold. And you can see the cost of a data breach. If you look at healthcare records or credit card numbers or IP theft, that data is very valuable. And there are several estimates of what it costs an organization to lose that data. So the question, you probably are wondering is, why is this such a huge problem? I mean, why haven't we solved it? And the answer lies in kind of the architectural problems within a business and how traditional security has been implemented and why that doesn't work today. So now let's take a look at this from an industry lens. If you go to a Fortune 100 organization or even a Global 2000 organization, most organizations implemented security using a concept of a perimeter, right? If you look at a business, for the past 20, 30 years, they had a concept of a data center and their offices, it could be branch offices, headquarters, warehouses, retail outlets. All of these were connected using private networking to their data center or headquarters. And you call it this hub and spoke network architecture. And the entire network security model was based on this perimeter. When you were on the network, you were trusted and secure. And occasionally you went to the internet and you went through some firewalls that basically restricted access and provided some level of security. But the whole concept was, when you're on that network, you're secure. All your data and assets are on the network. Your email systems are Exchange servers inside your data center. Your SAP systems, your CRM systems are all part of this hub and spoke design. So think of this as a coconut security model, right? Hard and crunchy shell outside and kind of soft and gooey inside. Once you're inside, you're free to do whatever you want. But if you fast forward to today, that world is just rapidly changing, right? Cloud and mobility are driving a lot of transformation. Organizations are embracing SaaS. So many of the applications that were in your data center have now moved to the cloud. Your email system is now Office 365. Your CRM system is Salesforce. Your HR system is Workday. Your ITSM system is ServiceNow. Internet is becoming kind of the default corporate network. You're embracing public cloud and moving many workloads and servers that sat in your data center to AWS and Azure and GCP. And mobility. I mean, the pandemic just accelerated mobility. You have users that are now everywhere. So organizations are now faced with this stark reality where the center of gravity has moved from that data center to the internet, and users are everywhere. Yet that security model is almost like a castle and moat, where you built this castle and people have left the building and kind of assets have left that building, right? So this security architecture is something that is very predominant and is kind of the root cause of many of the problems that we see today. This architecture is just not designed for a modern cloud and mobile first world. So let's take a look at what needs to change. And this is something that we've been driving for a while, and successful progressive organizations are adopting this. So the security problem happens because now data is everywhere, and there isn't that castle and moat, and your users are everywhere. So the three areas that you need to focus on to reduce business risk, right? First one is you need to prevent the compromise to begin with, right? So if your user is sitting at home or in a coffee shop or wherever, the chances of getting exposed to malware is very high. So you need to prevent compromise. And this could also be non-user systems, could be IoT devices, it could be workloads. And majority of the malware, the stage 1 infection, comes through the internet. It could be a phishing link that you get in email. It could be an Excel file with an embedded macro that is a stage 1 payload that leads to subsequent ransomware infection, right? So you need to prevent that compromise to begin with. But what is more important is that once a machine is infected, how do you prevent lateral movement of that threat, right? This is a trend and pattern that you see over and over again. Something gets compromised, but because you had a flat hub and spoke network where everything was trusted, remember that coconut model I talked about. Once you're inside, you can do whatever you want. So infected machines come in, and then they move. The malware moves laterally, and maybe the threat actor can get access to your domain controller or your Active Directory, and that's what they're trying to do on that flat network. So you need to prevent that lateral movement of threat. And then last bit is you need to prevent data exfiltration, right? So even if you get compromised, how do I reduce the attack surface? How do I reduce access to my core assets and my gold, which is my data and IP? And you need to monitor and make sure things are not leaking out back to the internet. So these are kind of the 3 areas at a broad level where you need to focus on to improve cybersecurity. So now, what approaches exist for businesses to do that? So everyone agrees that those 3 are important things to do, right? And this is where kind of what's that next architecture that works in today's modern world that achieves those objectives? So approach 1 is, you extend that legacy hub and spoke model. And many of you who probably haven't been exposed to big businesses will wonder what is this this hub and spoke, and this is predominant across every industry and vertical. The hub and spoke was based on this whole concept of a wide area network, and people used networking such as MPLS, and think of it as private circuits that are just connecting your branches, headquarters to the data center. And that model is well understood. And what people say is, I think there was some background. If we can turn off the microphone, that'd be appreciated. Good. So, this MPLS is a common way of extending these private networks. And what people say is, well, I know this pattern, I know this paradigm. As I'm adopting cloud, I'm going to still use my data center as my hub and start extending my network using, say, site-to-site VPNs or private connects to these cloud providers. And then if my workforce starts getting remote, I will force everyone to VPN. And what VPN is doing is extending that kind of corporate network to these endpoints. Now imagine you're a business with, like Siemens, with 300,000 employees who are just everywhere now, and you've started adopting all these cloud services. That WAN just becomes a massive attack surface, right? And there are other challenges. If you force all users to go through a data center because of your VPN, the user experience suffers. The users are going to cloud services like Office 365, and they could have a great experience going direct, but you're forcing them to hairpin all the traffic through your data center because that's where your legacy security stack is. So it leads to very poor user experience. Your lateral propagation problem still continues. One infected machine comes in, and now it has a massive attack surface to explode into. And then you have to now maintain an even more complex WAN that has gone from your just branches and headquarters to all these assets, right? So this model is just untenable, right? So approach 1 just doesn't work. Now, approach 2 is kind of what I'd say a little hybrid approach, where people say, okay, we get it. We're not going to just extend our flat network everywhere. Maybe we start virtualizing security components like firewalls and kind of extending that to say my branch or even public cloud services. And that way, what will happen is, instead of everyone coming to one choke point, I'll have a distributed security layer, which is running now in branches, potentially even in my public cloud infrastructure. So I took my firewalls that were in the data center, virtualized them, moved it to Azure, AWS, GCP, pushed some of these types of security services to my branch. So users don't all have to come to one choke point, right? Now, what does this lead to? So this is a step forward. It eliminates a lot of the MPLS, the private circuit, the WAN costs, potentially leads to marginal user experience benefits, right? So if I'm sitting in a branch, I can go direct through a local firewall. If I'm sitting remotely, I may be able to access services, through a nearby virtual firewall as opposed to going to a central choke point, right? But look at the challenges again. The challenges here, the attack surface is blown up, right? Every firewall is an attack surface. It's you have complexity because you have to now manage so many configurations, and it leads to more problems the bigger and more complex an organization gets. Approach 3 is zero trust, right? Zero trust is a buzzword now. You hear about it a lot. But fundamentally, what zero trust architectures do is they eliminate the network completely. Network becomes a transport. You're no longer relying on being on a trusted network, and therefore, you get higher levels of privileges. And what a zero trust exchange does is think of it as a switchboard. And it is using identity as a perimeter as opposed to network. It can use the internet as the corporate network as opposed to your trusted WAN. And it is allowing users and devices to connect to destinations that they want to go to based on strong identity and business policies, right? So let me give you an example of what that means, right? So let's say you are a user. You want to access an application. That application might be on the internet, could be SaaS, could be hosted in your private cloud infrastructure. At the end of the day, what you want to do is you want to say this user has access to this application based on context, and context could be, if you're coming from a corporate device, you get access. If you're coming from, say, potentially China, then you get restricted access. So things like user, context, location, probably risk profile, all of these get factored in to this adaptive policy engine that then gives access to a particular application for a user. Now, that is the user and context, but what is also more important is content, right? As the user or a device is communicating, you need to be able to scan content and make sure that, hey, nothing bad is coming in and nothing good is leaking out based on policies. So this, conceptually is what a zero trust architecture does. And it has some very, very compelling benefits if you can implement this at scale. First, it improves user productivity. Users will get the shortest path first. I'm sitting here in San Jose. I need to access Office 365. I don't need to send my traffic over a VPN to my company's data center in New York, right? It mitigates, control and risk. Maybe I'm a contractor and I need only access to an application. I don't have full flexibility to roam around inside the corporate network. And then, there are lots of other benefits. For example, things, businesses do M&As all the time, right? When one big business buys another business, the network complexity of merging these networks in the old architecture is just an 18-month project. If you use zero trust, it just eliminates, because there's no network. You've decoupled application access and security from being on a network, and it leads to a lot of agility. And there's some significant benefits on cost and complexity. Again, you're kind of eliminating WAN and MPLS and managing an explosion of virtual firewalls on an increased attack surface. So let me, I understand many of you might not be from a security background, so I thought it might be worthwhile to look at simple analogies of how what happens in a real world, in a physical world, and translate that to zero trust principles in the security domain. So let's talk about the first concept I mentioned, right? Connect users to applications. Don't put users on a network and then say this network is trusted and they can do whatever. So a simple analogy for that is think about your office, and you have visitors coming in, and one model could say a visitor comes in, you check their identity, and by the receptionist does that, and then the visitor is allowed to go into the office and do whatever the hell they want. Now that is kind of that traditional network security model. The user or the visitor can now visit, and they wanted to go and go to room number 23 or meet a specific user, but they were allowed to roam around and nobody has any idea what they did, right? So this leads to obviously a bigger security risk. Now that's exactly what happens in the old model. A user over a VPN comes to a trusted network, and once they do that, they are then allowed access to pretty much anything that's on the network. Maybe the user only needed access to an SAP system, but now they can roam around and explore and run network scans and detect other juicy targets and exploit them. And that's the common problem that happens with either compromised machines or determined hackers who have now gotten access to your corporate network. Now let's take a look at a zero trust model. In the zero trust model, when the visitor comes in, the receptionist checks identity, strong identity validation, checks context. What is context? Hey, are you allowed to visit? Who are you visiting? Do I have prior knowledge of that? And then wherever they go, they are accompanied to make sure that they are only accessing a user or a room that they were supposed to, right? And that's kind of what a zero trust model does. User comes in, the user has no knowledge because they are behind, all the assets are behind an exchange. Think of the exchange as a switchboard. And the user comes, asserts identity, says, I need access to this resource. If that is allowed by business policy, it's brokered through the exchange, and that's it. If someone else tries to access something else and they're not allowed to do it, it just doesn't happen, right? So it's a concept, but it's a very powerful one, and it's been difficult to implement in the past, and the world is now moving to architectures that allow it to happen very seamlessly. So let's take a look at another concept, reducing attack surface, right? I thought this example might resonate with a lot of you, and I get a lot of scam calls, right? And why do I get scam calls? Because my cell phone number is known and published, right? So my friends can call me. So Chris can call Amy directly, using her cell phone number. But then if Amy's number is known, anyone can call Amy, right? And that's kind of the basic model. The same thing happens with corporate applications, right? Your firewalls, VPNs, or have listening interfaces that are known on the internet, right? Your apps might be published, and so it's just known to everyone, and that allows a big attack surface, right? The threat actors also know that. An alternate model could be based on some sort of a concierge service, right? So think of Chris never knows Amy's number, but calls a service, and the service says, hey, look, yes, Chris, you're authorized based on Amy's policies and permissions, and the switchboard connects it. The same exact thing happens with the zero trust exchange. The user comes, asserts identity, and the applications are published on the exchange internally, and based on policy, that access is granted. Now, obviously, you'd say, hey, this model is secure, but is it fast? Do I have to wait for a manual switchboard operator to connect the wires? And the answer is no. If you build the right architectural and engineering foundations, you can actually provide user experience that is an order of magnitude faster with the kind of security that we're talking about, and we'll see why. Third concept I thought, which is important to understand, is Again, many of you probably come from a non-security background, and you often wonder, hey, firewalls, are they secure? What's the difference between a firewall and proxy? And I think, again, to do modern zero trust security, you have to have a proxy architecture. And fundamentally, the difference between a proxy and a firewall is proxies inspect content. They operate at an application layer. And if you look at, again, in a kind of physical world scenario, let's say you have, cars that are zipping past, and you can think of cars as packets, right? Or, even content. In the old model, you just do a cursory inspection, and if content is hidden inside, say, an SSL tunnel, or maybe an encrypted file, or as a Gmail attachment that came under TLS, a firewall is just totally blind to it, right? Because what is a firewall doing? It's just looking at layer 3, potentially some layer 4. It's a pass-through architecture, right? So it looks at a limited buffer and inspects it, and maybe tries to identify, well, this looks like going to Facebook, and this looks like it's going to Dropbox, and that's pretty much it. If it is SSL encrypted, that's happening at a layer above, and so firewalls are just blind to it, all of it, right? In contrast, a proxy architecture is doing a deep content inspection, right? So it is looking at what's happening inside, and it results in much better security, particularly in a world where everything is getting end-to-end encrypted. So the first thing that proxy does is it will terminate the TLS connection. It will do a full content level inspection and say, hey, this is a PDF that has potentially a problem, or this looks like a botnet calling home to a command and control server, even though it is SSL encrypted. And then, because it's doing content level inspection, it is making sure, again, nothing good is coming, nothing bad is coming in, nothing good is coming out based on actual content analysis. So these three are important concepts when you think about zero trust, right? Decouple app access from being on the network. Use a proxy-based architecture, and deliver the shortest path from a user experience perspective. So, I mean, a bit of a Zscaler plug here, and that's really what we've been up to for over a decade. And at the heart of what Zscaler does is we built the zero trust exchange, and it allows anything to talk to anything based on the concepts I just described: strong identity, proxy-based inspection, even with content, and allowing users, devices, apps to talk to who they want to based on identity and context, rather than being on the network. And those are kind of the core big architectural differences from the old security model, which is castle and moat, right? To access an app, you have to be on the network. That leads to all the lateral propagation problems. You need to have your attack surface exposed, because you're publishing apps, endpoints, VPN gateways, all on the internet. With a zero trust exchange, a big business is completely invisible on the internet, because all the rest of the world sees is IP addresses belonging to the exchange, not service endpoints that an organization might have. And then you're inspecting everything at scale, and it's not a pass-through architecture where you're just sort of bridging connections between sources and destinations. So that's kind of the core. Now, let me give you a flavor of what are the benefits should you start adopting an architecture like this. And it really falls into three buckets. Bucket one is a modern workplace enablement, right? So particularly in a work from anywhere world, you can see, you're not forcing people onto clunky VPNs, and it gives a great user experience, and you can secure users and assets no matter where they are. The second benefit, of course, is you up your game in security. Zero trust is the way. It leads to better cyber threat protection. It leads to better data protection. And the third benefit from a network perspective is you're eliminating all that clunky WAN and MPLS, and you can dramatically simplify your branch network connectivity, your cloud connectivity. And let me just give you a flavor of how that happens. So let's talk about kind of modern workplace enablement, right? In that old hub and spoke model, again, you might have data centers, and just showcase the kind of security appliances that people have built in that castle and moat architecture over the decades. All the way from on the inbound side, firewalls, URL filters, and AV appliances, and data loss prevention appliances. On the outbound, again, you might have load balancers and concentrators and whatnot, right? So all of these things are sitting inside your data center. You get to eliminate all of that, simplify, and go through a zero trust exchange. And you have to build this exchange, and we'll talk about some of the challenges. You have to solve an engineering problem, you have to solve a physics problem. The physics problem says you can't travel faster than the speed of light, so how can I give you the shortest path? And the engineering problem says, hey, once you come to the exchange, how can I quickly inspect and apply the policies and let you go to where you want? But once you do that at scale, you really enable this work from anywhere model, where users, devices, workloads can get fast and seamless access to where they want to. There's no, hey, VPN on, off. It's ideal for cloud applications. It is secure. You get the same consistent policies, not one set of policies when you're on campus and another set of policies when you're off. You can deploy it globally. Again, you don't have to manage all of this. Think of just like cloud has enabled a lot of applications and simplified IT for organizations. Delivering security through the cloud itself simplifies many of the headaches around security. Now, one of the important benefits that you get if you adopt let's use the internet as the corporate network, let's go direct, let's go through an exchange with consistent policies, is you get a better user experience. And part of the challenge for IT, and these are all kind of practical common business problems, is say you're the CIO of a company today, okay? You have 100,000 employees. Your employees are all over the world. You've adopted all these applications. You're using the internet to connect. How do you guarantee user experience? For a world where you don't control the applications, they're hosted by Microsoft and Google. You don't control the network anymore. People are using their own ISPs and internet to connect. In many cases, you don't even control their devices, right? People bring their own devices and say, hey, I want a Mac, or I want to access this on my iPhone. So in that world, for a traditional IT organization, guaranteeing end user experience is a huge problem, right? So one of the benefits of using a zero trust exchange architecture is, you get that full end-to-end performance visibility, right? If there's a problem, today we are on a WebEx and you're probably streaming this on YouTube. If there was a problem, where is the problem? Was it Amit's Comcast? Was it his Wi-Fi? Was there a problem on his laptop? Was WebEx having a problem? Was there a problem with Airtel's network in NCR? Where do you troubleshoot? And I think all of that visibility naturally happens if you're going through a exchange, and we provide kind of the detailed time series analytics that can pinpoint and say, well, this problem is happening only in India, or this problem is happening with WebEx as a service, or this user's Wi-Fi is a problem, or this group or this office in Chandigarh might have issues with their ISP connectivity. And that becomes a very powerful tool where you're not only giving good security, but also amazing user experience. And that's one of the things that I'm very passionate about is security is often viewed as a department of no, you can't do that, or we'll block that, or the real challenge for security is how do you become a business enabler as opposed to the department of no, right? And providing outstanding user experience with business risk reduction is really a very compelling benefit if you can do that. Um, I frequently talk to CXOs. They say, "Wow, I can now access this application on my iPhone, and I click a link and it doesn't say open a VPN," and all of those types of clunky things that happen in the old world. And being able to provide IT, the tools where they can really provide experience enablement in this distributed world we live in becomes very powerful. Then let's talk about kind of cyber threat protection, a few areas, right? First thing, you need to prevent threats from reaching end users and workloads. And because you scan all the content, you can do that very, very effectively. And without content scanning, I can guarantee you, most of the malware will get through. So having that proxy architecture helps. You prevent threats from reaching, and then at the same time, your internal apps are invisible. You eliminate the attack surface, so threat actors can't even detect it. So if you don't even know it exists, how are you going to attack it, right? And then lateral movement, right? You need to by allowing users only to talk to specific applications, a lot of the attack surface gets eliminated. I mean, think about how your iPhone talks to your Nest camera at home. You don't VPN to your home network and allow the app to discover whatever is on your home Wi-Fi. The Nest device talks to a cloud service, say Google, and you authenticate with that service. And once you do, the end-to-end connection is stitched, and you don't even know what else exists. So that's that concept of user-to-app segmentation, which again eliminates the attack surface on your internal network. And the next level of that is app-to-app segmentation, right? I built applications in, say, GCP and AWS, and here's my UI server. It needs to talk to a database. That should be the only path that is allowed, as opposed to saying, hey, all of you are on this flat network, this VLAN, and anyone can talk to anything. So that, those are important things that, prevent compromise and then prevent the risk of lateral movement when going through the exchange. The other aspect, of course, as I talked about, is you prevent the threats, but you also want to prevent your data loss, right? So this is where I say that security model that looks like a coconut has to become more like a guacamole, right? Where instead of relying on a hard, crunchy shell outside and everything being soft and gooey inside, you think about my core assets, the guacamole seed that's locked in, and everything around can be soft and gooey, and you don't care because you're going through a zero trust architecture. So here, content that is kind of that should not go outside is inspected. Maybe your developers should not be putting source code in their private GitHub repositories. Maybe your finance team, should not drag and drop a confidential HR document or compensation information and put it in a Dropbox folder and it leaks out, right? The same thing, many organizations want to allow access, but they don't want content locally on unmanaged devices. So how do you do that, right? Maybe you want to let people see something, and there are lots of very cool cloud browser isolation technologies that we provide, where the content is just a set of streamed pixels, and you can prevent copy, paste, upload, download types of actions that again increase security and prevent data exfiltration. And then I won't go into all of this, but the use cases just grow once you have that core architecture. You want to scan data at rest in your sanctioned cloud applications, and you want to make sure stupid things are not happening, where maybe you're using Box for collaboration or Office 365, and you don't want open folders and link sharing with confidential information. And all of those things can just be effortlessly implemented through simple policies. Similarly, as you start adopting cloud applications, in private cloud infrastructure. You want to make sure that basic configurations are locked down. Maybe in AWS someone left an open S3 bucket that was exposed to the world, and what a exchange can do is use APIs and scan your sanctioned SaaS applications, sanctioned cloud service providers, and make sure that configurations are compliant with the policies and the amount of risk tolerance that you have. And then last bit, we talked about how do you enable a modern workforce. We talked about how do you reduce risk, and the third area is how do you improve your networks and adopt a more modern infrastructure. So two areas: how do I connect my branches? How do I connect to cloud? If you look at kind of that old model, again, hub and spoke, all very data center centric. And then when you extend to the cloud, you set up site-to-site VPNs. You can replace all of that and say, well, internet is my new corporate network. Identity is the new perimeter, and I will enable my branches to go direct. Maybe you have internet-only branches, kind of like a Starbucks coffee shop, right? Users there get access using internet, but they go through that same policy layer. You might have, hybrid branches with SD-WAN and other forms of connectivity that all again go direct, and it kind of dramatically simplifies and reduces cost for your branch connectivity options. And then if you look at this on the cloud side, again, the cloud networking, people, if you've been a hammer, everything looks like a nail to you, right? So people have just adopted that old model and said, hey, VPC is my data center, right? So now I'll take VPCs and connect it to a transit gateway and build virtual firewalls there. I now need to go to AWS and Azure, and I'll build bidirectional VPCs and use express route and direct connect. And all of this, again, a lot of overhead, a lot of attack surface, a lot of complexity. And look at users. I mean, users are trying to go to a modern cloud app that you have built, and they go through this old clunky networking that is just not conducive. You can again simplify and eliminate a lot of that and say, hey, look, VPCs can go direct to the internet, and they'll get the same policies that we've had. VPCs that need to communicate with other VPCs, or you might have cloud-to-cloud connectivity needed. All of that can be brokered very effectively and fast through the exchange. So again, the core benefits, again, better user experience, reducing complexity and cost, and sort of better security in the process will be repeated themes that come in. So think about, the question is, what is the blueprint for a modern cloud and mobile-centric workforce when it comes to security? And so I put together some of the areas that people should think about. We talked quite a bit about the policy engine, the zero trust exchange that sits in between. But you need to think about APIs, and you need to think about how it coexists in a modern world with your security operations center, with your endpoint management systems, with identity, which is core to zero trust, with all these things. And you can really build a modern infrastructure for security and networking that is applicable for the next decade if you start looking at it with this lens. So 2 last slides, and then we'll take questions. So I mentioned, so conceptually that's great. When the rubber meets the road, you need to solve very, very hard problems, right? The first problem you need to solve is the physics problem, right? If you don't want that hub and spoke model, if you want to go direct, you need to guarantee that everyone gets the shortest path, right? Imagine if Starbucks was only served from Seattle, it wouldn't be very, very popular, right? You need to provide people coffee wherever they are. So, one of the things that we've done is build this exchange across 150 data centers worldwide. And we use sort of the best transit providers in any given region, the best tier one ISPs and kind of data centers that provide maximum connectivity options, right? So when we are in, say, India, we might work with an Airtel. When we are in North America, we might work with Equinix as a data center provider, with GTT and Zayo as transit providers. And when we are in Australia, we might work with the Telstra. As you know, the internet is a loose coupling of many tier one ISPs, and you want to make sure that a security service like this is built where the bulk of the internet is pulsing through with maximum connectivity options and kind of the ability to provide the shortest path. And we do all kinds of interesting things like direct peering with Microsoft, with Akamai, with Google. So you're a millisecond hop away from the front door of that service. Usually 1 or 2 BGP hops to get to them. So that's kind of the physics problem. And now we've been doing this at scale. Actually, our transaction volume has crossed 200 billion transactions per day, which is about 20 times the number of Google searches done daily. Because many 5,000 plus large organizations are using this and sending all that traffic through us and implementing some of the zero trust things that we talked about. Here's a kind of lay of the land from a competitive perspective. You can see some of what I call the incumbent vendors and Zscaler, kind of very strongly positioned. Some of the concepts I talked about, some of the infrastructure that we built, both from a vision perspective and an execution perspective, stand out. I call this socially distancing us from some of the legacy vendors, and which explains our commercial success in the market. And then last plug is if I have to kind of net it out, I think I'd say a few things. One, zero trust is the new architectural paradigm for today's businesses. You need to get away from this concept of my network and network-centric approaches and firewall-centric approaches for all the reasons I talked about. If you're able to use a properly designed system that can scale, that can provide, you can solve those engineering problems as well as the physics problems. You can get the three compelling benefits. You get better user experience because your users go direct. They don't have to worry about this network or that network. You definitely get significant risk improvement, and if you look at Fortune 100 company like NOV in the oil and gas sector, once they adopted this type of architecture, their infections just pretty much vanished, right? So you don't get ransomware, you don't get breaches because of the better architecture from a security perspective. And the third aspect, of course, is lots of cost and complexity reduction that leads to significant savings from a IT infrastructure perspective. So with that, hopefully you found this session useful. Wanted to thank all of you for spending your Saturday morning and evening, and this is a little more from an industry lens perspective, and obviously I bleed blue with Zscaler, so if it sounded a little bit of a Zscaler pitch, I apologize, but this is more, the idea was to talk more about the architecture behind what we've built and share that with you. So thank you, and open to questions, Professor Garg.
Thank you, Amit. That was a truly wonderful talk. I think I didn't realize, when we started, the scale of things. Your second to last slide about the number of transactions. That's really amazing. I'm sure there is a huge amount of engineering and challenging problem solving that you must have done, over the years make this all happen. I I'm going to start off. I was as as I was listening to your talk, some very one I would say, it's terrific talk, and I understood it. So I'm sure everyone else in this audience would have definitely understood what was happening there. So, but there were some questions that kept coming in, and one particular thing that I was wondering. You talked about this zero trust exchange. You talked about the proxy server, looking at the payload very carefully. So all of this does make these as choke points, right? Both the zero trust exchange and this proxy server. So is there some other solution you have, or what is it that makes the thing tick, right? Because one would imagine at the face of it that once you have such a very centralized way of doing things, there would be breakdowns. Your exchange would fail, or there'll be too much lag because of the proxy server doing all the proxy based inspection and all of those things. So have you been able to overcome them through better protocols or engineering solutions, or what has gone behind?
Yeah, so it's a great question. I mean, everyone wants to know kind of the secret sauce, how all of this works, right?
What is it that's making it
So
tick?
hopefully my kind of the physics problem is clear, right? The baseline in businesses is so bad. You bring everything to a choke point, and there is network latency that you just cannot avoid, right? Like, it's very common for a business to have a data center in Chicago and New York or maybe Frankfurt, and force everyone to go through it, right? So that baseline is just horrible. If you go from 3 such choke points to 150, shortest path first with all the peering that I talked about, and destination neutral, sitting at the hub of where the internet is flowing through, that network latency reduction itself is monumental. Step one, right? Now, step two is the engineering problem, right? So let me give you a couple of things that we do. One of the slides I showed was the independent security appliances that get service chained. That's how security is done, right? Everyone is a specialized function. Hey, I do URL filtering, I do antivirus, I do this, right? And those boxes are typically service chained, right? And you can imagine that 70-80% of the functionality in each of those boxes is just replicated. They all have a network stack. They all are extracting maybe some content. They do a little bit of policy, repackage it, and ship it to the next person, right? So that service chaining is like going through 10 speed bumps, right? Back to back. Now, Zscaler, from an engineering perspective, we have what we call a single pass architecture, right? And all of this is super high performance, done in C, right? The kind of the core data path. If you ask me, one of the first things we did when we started building this was to move the TCP stack to user space, right? Like, you don't know of many security companies who start a security solution by saying we need to re-engineer the network. Now, why? Because the generic network stack is running in kernel space and is designed to work for 50 things. You don't care about all of those things, right? There's so many packet copies that are happening, and the overhead is just huge. So we moved the entire TCP stack into user space, and we said we're going to use the operating system just to boot up the device, right? And just basically stream packets into user space, and that's it. And then no copies are there. It's a single pass architecture where we do a single scan and multiple actions, as opposed to the service chaining concept that we talked about. And Professor Garg, you know that at the end of the day, everything in computer science is a speed memory trade-off, right? So when you give engineers, here's a box and here's a security appliance and here's what you need to do, the solutions that come out are very different than if you tell someone, assume you have infinite memory, right? Assume, what can you do? Maybe you can index and hash, every known URL that system has seen, sitting there, right, in memory. Maybe you can, throw sophisticated machine learning models that can that have seen 200 billion transactions worth of stuff, and can quickly, predict that this looks like a variant, right? So the answer isn't one specific thing. What you need to do is remove some of the network bottlenecks that I talked about. then do a single pass architecture. When I'm scanning a PDF file, I need to run all AV engines on it. I need to run a data loss prevention engine on it. I need to run potentially a regular expression to see if this was confidential information. And if you architect it correctly, you're not service chaining with different solutions. So that sort of kind of gives you a hint into the engineering architecture behind that, right? And once you couple that with the physics problem of removing network latency, it is mind-boggling the kind of benefits you get from the baseline that most businesses are used to. I mean, every business that you talk to will tell you, man, my home network, the employee will say, things at home are faster and better, and why can't my enterprise system be, fast and nimble, like accessing Amazon or Gmail on my private, home system, right? So, A, the baselines are very bad, and B, if you solve these problems that I talked about, you can build a very reliable service. And it is a mission critical service, right? Like, can we be down? We try damn hard not to, right? And we have a good track record for that. And you have to build all the resiliency at every layer that are part of the foundational architecture. And bad architecture lives forever, right? So you have to build these things over time and address it through the years.
And one other question, so I might have missed this. So the policy exchange that you have, right? Is that would that be a single policy exchange, or that will also be some kind of a distributed architecture?
The whole thing is distributed, right? Like if you look at the core, at the highest layer, you have what we would call a control plane, which is distributed. Think of the control plane as a policy database, right? And there's lots of modern streaming replication protocols that you can use that you can say, look, my policies sit in a global control plane across, say, 6 hubs worldwide, right? What is most important then from a performance perspective is your enforcement, the data plane, right? So you've separated the control plane from the data plane from kind of the logging and analytics, right? So those are the 3 tiers. The control plane, think of it as a distributed, high-speed, real-time replicated database. Think of the enforcement plane as the one that is doing that policy enforcement, right? And the job is do it fast, single pass architecture, the things that I talked about. So the enforcement is getting policies in real time, and everything is in memory, right? I think of it as everything running off memory as opposed to disk-based database queries, right? So the policies descend across all 150 data centers in real time, and then logs have to be written also in real time. So these are all sort of memory-to-memory streaming systems, which is where you get a lot of performance benefits. Now, one last thing I'd add there is, logging is also a very complex problem, right? Businesses have geographical and kind of compliance restrictions. Maybe a company like Nestle will say, "Hey, I want all my logs sitting in Germany all the time," right? Or so you need to solve those policy-based routing problems as well as part of that overall architecture.
True. One question from Jay. Okay, I don't have the full name. Along similar lines, could overloading the proxy with huge number of requests cause denial of service because of the overhead? I guess along similar lines, but
it's a great question, right? So look, we operate a multi-terabit scale network, right? So can you DDoS a certain VIP virtual IP? Possibly, right? But kind of mounting a global DDoS attack across an infrastructure like that requires massive resources. And again, remember, we've not built this on one service provider, right? We use all tier 1 ISPs across the world. And we use a fair amount of DDoS mitigation techniques. You can always saturate the wire to some extent, but we use upstream DDoS mitigation techniques. So it's a combination of some of the defenses that we've put in, kind of the multi-terabit scale of that infrastructure. No single choke point, right? I mean, let's say you a determined actor tries to bring down our New Delhi data center, right? Traffic will automatically fail over to Mumbai and Chennai, right? And those are on different providers and different paths. And so, kind of the resiliency that you get on the internet, we've built that platform on the same kind of principles of, fault tolerance and failover and it's very difficult for one organization to do that. It's when you start pooling a common platform that we've built, that's where you can get that economies of scale.
So I'm going to unmute one of the participants and would like to ask the question. Okay. Go ahead, please.
Yep. Thanks, Amit, for the wonderful presentation. Actually, as you were saying before, the login policies, like some company wants their databases to be put in Germany and so, right, the physical databases. So I was just wondering how people would be comfortable or uncomfortable putting the databases in China, because China has everything under their control, right? So how would people deal with those kind of situations?
Yeah, it's a great question. So step one, our policy, kind of the control plane, we do not put in China from a persistence perspective, right? So the control plane doesn't go into China. The reality is every Fortune 500 has manufacturing and other presence in China, so they want enforcement there. So just the enforcement plane goes there, and the policies that come into China are kind of simple policy objects that say, hey, this user is allowed to go here or this user is not allowed to go there. There isn't any kind of sensitive information around metadata or logs or things that are sitting there, right? I mean, our problem, Jay, is not the problem for folks like Office 365 and content holders is much higher because your entire mailboxes and files are sitting. We're just a policy engine, right? The policy engine is saying you can do this, you can't do this, and the persistent store is here's companies, here's policies, and that database we don't persist inside China. Just kind of replicas of policies, small policy objects get streamed within China. And then the other aspect of your question would be logging, right? Like, hey, who has access to logs? And that's again completely a organizational policy decision. They might say, I want all my logs in EU, or I want all my logs in the US. And if you build a clean architecture with separation of the control plane, data plane, and analytics, you can guarantee by design that no metadata logs are written onto disk anywhere except designated clusters that are in specific geographies. And because everything is streaming in memory, and the commit to disk happens based on policy.
Okay. That's awesome. Thank you.
One last question, Amit. I realize we are running out of time, but I have to ask you this. So,
Yeah.
Of course, you said very nice things about the architecture, but what are the weaknesses? There must be some things that Of course, I don't want you to leak out any secrets, but what are the things that you think
I mean, I
need to be
think
done?
see, I've lost some hair, right, over 11 years. I think it's not a weakness per se. At the end of the day, it is an enormous amount of responsibility that we are taking, right? I mean, you're kind of the dial tone to the internet and SaaS, and you're kind of the switchboard in between for all these global 2000 businesses. We have 500 plus of the global 2000 completely relying on us, right? And nothing is 100%, right?
Of course.
You can be 99.999% up, right? And knock on wood, we've been very, very robust and reliable, and built it on internet principles. So you can fail over, and so there might be a little impact in, say, Frankfurt, but you fail over to Manchester or other sites, Zurich or what have you. And obviously, we take Zscaler internal security very seriously. You don't want to get compromised yourself, right? So, I mean, it is a enormous trust that our customers place on us, and we're sitting in line, and are we delivering a service that is an order of magnitude better than they doing it themselves? Yes. Because again, with economies of scale, and there's no compression algorithm for good experience, and you refine it, right? But there's always that sense of being mission critical all the time. If Salesforce.com goes down, maybe your sales guys could not update CRM for some time. Maybe they went out, had some coffee, and came back, and things were fine. But we just have to gotta work all the time. Right?
All the time, yeah.
Yeah.
Thank you. Yes, we are way out of time. Thank you for a wonderful, wonderful session. I'm sure all those who could join us today would have really enjoyed it. And of course, this video is going to live, so which means it will remain on YouTube. I hope we have your permission for that.
Yes.
And so I'm sure we'll many of our students who could not join. After all, this is a Diwali weekend. We'll have the opportunity to look it up and learn more about zero trust and this way of architecting security and the internet. So thank you so much, Amit. This was wonderful, and thank you for your time and also for agreeing to have given this talk and for a wonderful, wonderful talk. So thank you.
Awesome. Thank you, Professor Garg. I appreciate the opportunity, and best wishes to the extended IIT Delhi family.
Thank you so much. Bye-bye.